Watch out. Looking at birds could lead to an increased risk of learning something about them.
Here's a question for you. What does this heron and this iguana and this alligator all have in common? Well, it's more than I thought. My name is Dean and you're watching Lake Log, and in this episode, I've been thinking about dinosaurs and dragons and monsters. And it turns out they're all related. But I didn't know that. Watching and recording birds has led me down the path of discovery and has shown me that a little curiosity can sometimes be dangerous, but a little knowledge is even more dangerous. Evolutionary scientists believe that birds are the descendants of reptilian dinosaurs, but because I'm a visual person and not an evolutionary scientist, I wanted to see some of the similarities, so I started looking into it.
The first complete dinosaur skeleton ever found was Ichthyosaurus, or fish lizard, which was a large aquatic cousin to crocodiles and alligators, 250 million years old. It was found in 1834. Looks like an alligator. The Hylaeosaurus, or forest lizard, was uncovered a little earlier in 1832 and dates back over 136 million years. It was believed to look something like this and was an ankylosaur. Ankylosaurs had bony outer armor like a turtle. But turtle evolution is more mysterious. This looks like a really big iguana. And what about the birds? We all know the pterodactyl from all those animated dinosaur movies we saw as kids. Pterodactyls were pterosaurs, or wing lizards. They did not have true bird feathers, but like birds, were egg layers. They lived 228 to 66 million years ago. Starting to look like a bird, isn't it? Then I came across Hesperornis, or western bird. They lived 70 to 80 million years ago, and although they did not have actual wings, they were flightless, swimming ancestors to birds, kind of like a big, really big cormorant, but with teeth. For me, it's the shape of the skull and the neck that is the most visually interesting. This looks like a heron. The oldest known flying bird relatives might have been Archaeopteryx, or old wing, considered a transitional fossil link between non-avian dinosaurs and birds. Archaeopteryx was flying 150 million years ago and was not very big, about the size of a raven. It had flight feathers, but also had a long bony tail and teeth. That is definitely a bird.
Did all of these animals contribute to the evolution of the modern-day heron? In strictly visual terms, it's not so crazy, but there's a lot of evolutionary science that I just don't understand. So let's get back to looking at this dinosaur of a heron. It's a tricolored heron, to be exact.
The tricolored heron is common around Lake Osborne. It's a year-round resident, and this is an adult I recorded back in December of 2020, prowling the shallows of Custard Apple Slough. Custard Apple Slough is a part of the lake that's located here, next to the campground, adjacent to the airport, and bordering Congress Avenue to the west. The tricolored heron is not on any endangered species watch list just yet. The wood stork, though, is a little more rare and seasonal around here. It is estimated that only 20% of the entire wood stork population still exists from just 100 years ago, as they were once hunted for their feathers and their eggs. Most of the population can be found in the coastal areas of Florida, Georgia, and South Carolina, and they are considered a threatened species here in the USA. No longer hunted, their biggest threat now is habitat loss. Here's another interesting thing about the wood stork. Their feet are pink. I watched the tricolored heron and imagined what this area might have been like 100 years ago, or 200, or 2,000. Will the tricolored heron disappear and become extinct like the dinosaurs? More importantly, would we even miss it? I've watched these herons extensively since the start of Lake Log. They're patient hunters, not too camera shy either. Here's another adult in non-breeding plumage. When they're breeding, their beaks turn from yellow to bright blue. I like the tricolored heron, and it's comforting to see them walking the lily pads or on the banks of the lake. They're as much a part of my neighborhood as, well, my neighbors are. They make a variety of unique sounds, too. Sometimes they sound like this. The juvenile tricolored heron is more rusty brown color. They'll often run after small fish in a quick burst of graceful speed. Watch how this one angles its neck low and to the side to keep from being spotted by its prey, or to cut the glare on the surface of the water. So is a heron a dinosaur? It is like a reptile because it shares a very specific trait. Birds have beta-carotene in their scaly skin, feathers, and beaks, and beta-carotene is also found only in reptiles. Their bone structure is also curiously similar. Remember the swimming Hesperornis? There is a lot of evolutionary space between herons and Hesperornis, but to me, visually, not so much. Not all herons will hunt on dry land, and they're not swimmers like the cormorant, but they are water birds nonetheless. Wading and running after tiny fish is enough watery activity to make them quite aquatic by nature, and their ability to compensate for refraction allows them to strike at a fish below the surface without missing the target. To human eyes, their world is a chaos of lines and shapes, an ever-changing visual puzzle. But after watching this great egret hunt, I wondered if they see the world the same way I do. Birds have superior vision to humans, and bird eyes are uniquely designed to their advantage. Because bird eyes do not move within their sockets, birds will move their heads from side to side while stalking prey to get a better view or perhaps to gauge distance. They can also change the shape of the eye lens to zoom in on something from macro view. Herons can see forward, backward, up, down, and to the side at the same time, and each eye can do this independently. So they have both binocular and monocular vision. It's not easy to sneak up on a heron. They also have two eyelids, one for closing the eye completely to protect it, and a thinner one that's called the nictitating membrane, which moistens the eye without closing it. And because they can see UV light, details are enhanced and separated for clarity and a greater sense of depth. Where we may see a tangle of green foliage, birds may see some very different colors, like these. Raptors, like owls and this osprey, have eyes that are set closer together and more to the front. This gives them superior binocular vision and helps with depth perception. The phrase eagle-eyed and hawk-eyed, used to describe someone who sees very well, are not simply poetic descriptions. Eagles and hawks do see farther into the distance than we can. Iguanas have excellent vision too. Iguanas are common, unfortunately, to South Florida, and there are lots of them in and around Lake Osborne. They are excellent swimmers and climbers and mostly vegetarians, and have few natural enemies. The Florida Wildlife Commission has labeled them as an invasive and destructive species and encouraged their eradication by humane means. They're destructive to natural species in that they will sometimes raid bird nests for eggs, and they will steal the burrows of endangered gopher tortoises and burrowing owls. Iguanas are covered with scaly skin and dorsal spines. The bigger and older they get, the more prominent the spines become. The subtympanic shield is that large scale on their jaw that resembles an eye. It might only function to intimidate predators or rivals. Their ears are located just above that and are small and similar to a bird's ear in that they don't stick out like in terrestrial mammals. The dewlap is a large flap of skin and scales that helps them regulate temperature. Iguanas are cold-blooded egg layers. The colder they get, the more lethargic they become. Drastic drops in temperature can stun them or even kill them completely. Freeze warnings in South Florida often come with falling iguana warnings, as cold-stunned lizards will fall from the trees into yards, on top of cars, streets, and into the water. Their most interesting feature is called a parietal eye. It's not a real eye, but an organ at the top of their skull that can sense changes in light through their skin, warning the iguana of a predator from above. Other reptiles have this feature, including one that I'll get to in a minute. Iguanas spend their nights hanging around the trees, along with a lot of the birds and some of the nocturnal critters, like this raccoon, pretending to be invisible. One of the problems with iguanas is that they transmit salmonella through fecal contamination of water and the surfaces they defecate on. They love to eat flowering or fruiting landscape vegetation, which creates a lot of frustration for humans, too. They have a high level of intelligence, can remember, and can be trained. They were introduced to Florida in the pet trade back in the early 1960s and reproduce rapidly, making them a serious ecological threat.
Full disclosure here, I'm actually partly responsible for the iguana invasion. I had a pet iguana as a boy. Its name was Igor. It slipped out the back door of our home one day and was never seen again. Are its descendants pooping on my pool deck? Yes, that's karma for you. And what about that other reptile I mentioned that has a parietal eye? Surprisingly, in this case, it's a sea turtle.
But it's not this one, though. This is a very friendly loggerhead I recorded off the coast of Belize. But it's the leatherback sea turtle that has a parietal eye, just like an iguana. See that pink spot on the top of the head? The leatherback uses their parietal eye to sense changes in light, and it is believed that this helps them navigate the open ocean. Sea turtles can travel thousands of miles, but will always try to return to the very same beach where they hatched. So how does a sea turtle without a parietal eye navigate its way back to its original beach? Okay, so my questions get a little complicated here, but this got me thinking again about birds, a very specific bird, the frigate bird. We're still in Belize, and this is a frigate nesting colony. Frigates fly hundreds of miles over open ocean, can reach altitudes used by commercial airlines, and can remain aloft for weeks, even months at a time. Some evidence suggests that they return to the same breeding colony. How do they find their way back? Frigates are curious birds because they don't spend much time on land and they don't walk well. They're not aquatic, and so if they do make a splash landing in the ocean, they'll drown. And they are huge birds with a wingspan of over 7 feet.
I know what you're thinking. Now the old guy in the canoe is veering off on a wild tangent about frigate birds and turtles. Not so crazy, because recent DNA studies have shown that turtle DNA is more closely linked to bird DNA than it is to snakes or frogs. Yeah, turtles are related to birds.
There are quite a few alligators in Lake Osborne, and I came across one on a steamy morning in July. I went out looking for some herons to record and wound up following a gator around custard apple slough for a while. My guess is that it was a nesting female, because it stopped at one point and instead of submerging, stayed on the surface to watch me while slowly swimming from one side of the water channel to the other, back and forth. During their non-mating and nesting season, they are usually quite shy. Most of the time, alligators will submerge and move away from humans in boats, but this one was definitely guarding a nearby nest. I'm well aware that gators can be quite dangerous during mating and nesting season, so I kept a safe distance and relied on my telephoto lens to do the close work. Alligators are cold-blooded reptiles that build mound nests, burying their eggs under a thick layer of vegetation. Because alligator embryos do not have sex hormones, the sex of the hatchlings is determined by the temperature of the nest. Warmer eggs tend to hatch as male, while cooler ones become female. Interestingly enough, this also applies to sea turtle eggs. Alligator embryos and bird embryos look strikingly similar. Gators and their cousins, the crocodiles, are carnivores that prey on fish, turtles, birds, as well as small animals like raccoons, rabbits, and a possum. They don't discriminate between wild animals, domesticated ones, or small humans either, so dogs, cats, and kids who stray too close are easy prey for them too. I always think of this when I see kids splashing on the lake's beaches, especially when it's late in the day. Because Lake Osborne is connected to a chain of lakes and canals, gators are free to wander around. If a nuisance gator is removed from the lake, there is no real guarantee that it won't be back again later, or that another won't wander in to take its place. They have slow metabolisms, don't feed very often, and have remained, as scientists say, almost unchanged for thousands of years. And wouldn't you know it, alligators, like their bird cousins, also have a nictitating membrane. Just like in birds, it covers the eye to protect it, but also helps alligators see when they are underwater.
So you're thinking, how big is this gator? Hey dude, you're in my show. Everybody wants to be in Lake Log. Okay, so I'm out here, it's hot, but I'm gonna answer a burning question. And the burning question you have is, how big was that gator? Everybody, whenever they see a gator, wants to know, how big is it? Well, a small gator can bite you too, but that was a very big gator. I didn't have any way to estimate its length with my camera until I looked at a still image. And so what I'm gonna do is take that still image and try to calculate just how big this gator was. If you know the distance from the gator's eyes to its nostrils, if that's all you can see, you can calculate the length of the gator. And the way you do it is you take that distance in inches and you convert it to feet. So I came out here to the spot where the gator was, and if you see in this still image, the gator's nose brushes past an average lily pad, like this. This is an average lily pad, this is an average tape measure, and the distance is about 6 inches. So using this formula, when I get back, I'm gonna try to figure out just how big this gator is. And maybe we can even calculate the weight. Science. Or math. And math is a science.
So we'll take a look at this lily pad right here. I measured a random lily pad in the lake at about 6 inches, but they do vary, anywhere from 4 to 7 to maybe 8. If you take the distance between the alligator's eye and its nostrils, we can put 2 lily pads in this space. At an average size of 5 to 6 inches, this puts the alligator at an estimated length of 10 to 12 feet. Alligators average about 25.5 pounds per foot, which would put the estimated weight somewhere between 250 and 350 pounds. I don't think this alligator was 12 feet long. I think it was more like 10. And if it was a female, they tend to max out at about 10 feet. Mango is 13 feet 6 inches long from bow to stern. If you put a 10-foot gator next to Mango, it'll look something like this.
Wait a minute, did you hear that? No, not the helicopter.